Okay, here we go. The concept is, I call it factoring out blobs, but actually we're going to be dealing with fractional and negative exponents. So we're going to start out with a process and a concept we know pretty well. And that's this. Suppose I had 2x squared plus 10x cubed, and I wanted to remove a greatest common factor. And what would I do? Well, what I would do is I'd look to see that they have a common factor of 2. I also would notice that they have a common factor of x squared, so it's 2x squared. And normally what we would do is say, okay, we're going to have a 2x squared, we're going to remove a 2x squared. That's going to give me a 1 in that position. And I'm going to then remove a 2x squared from 10. So that gives me a 5, and an x squared, that gives me an x, and that's easy enough. But here's the concept. That says from the 2x squared that's in there, I am going to remove the 2 and the x squared. So from the x squared, I'm removing 2 of them. And plus, from the 10, I'm removing a 2, which gives me a 5. From the x cubed, I'm removing 2 of those x's. And that's what the minus means. I'm taking out that many. This becomes 2x squared times, taking the 2, now this x to the 0 power, plus 5, 3 minus 2 is 1, x to the 1. Now you know why there's going to be a 1 left in that position when you take it all out, because x to the 0 is 1. This is 2x squared, 1 plus 5x. So that's the concept. So in process of working with the concept, I'm going to make one itty bitty little change, and I'm going to look instead at 2x to the 1/2, so I'm going to do a fractional exponent, plus 10x to the 3/2. The concept itself hasn't changed one bit. What this says is, what's the greatest common factor? Greatest common factor of the numbers is 2, so that doesn't change. When I was up here, I noticed, what is the greatest common factor? It is the smallest power of that variable. In this case, it was x squared. In this case, the smallest power between 1/2 and 3/2 is 1/2, so I'm going to remove an x to the 1/2. Now I'm taking the 2, so I've got an x to 1/2. I am removing a 1/2, plus from the 10, I'm removing a 2. That's going to give me a 5. And from the x to the 3/2, I am removing 1/2. So my final answer is 2x to the 1/2 times x again to the 0 power plus 5x to the 2/2, which is just 1. So this becomes 2x to the 1/2 times 1 plus 5x. Again, I'm going to take the same problem, but I'm going to make one itty bitty little change to it. And so I'm going to start out with 2x to the 1/2 plus 10x to the negative 3/2. So now I've got a negative exponent. The concept itself hasn't changed. the common factor numerically is still 2. And I've got a common factor of x, but the smallest power between 1/2 and -3/2 is a -3/2. So I'm always removing the smallest number of x's. So that says I'm taking the 2 from the x to the 1/2. I'm going to remove a -3/2. Notice what that does. Negative and a negative is going to give me a positive. Plus, from the 10, I'm removing a 2, which gives me a 5. From the x to the -3/2, I'm going to remove a -3/2. So I get 2x to the -3/2 times, minus and a minus is a plus, so 1/2 plus 3/2 is 4/2. I get an x squared out of this, plus 5x, again a minus and a minus is a plus, minus 3/2 plus 3/2 is 0, which means I took them all. So 2x to the -3/2, x squared plus 5 is then my final answer. Now the big concept that's going to be coming out of here is making a substitution. So how do I factor making a substitution? So factoring using substitution. At some point in time, many of you will not need to be using substitution at all, and what you'll do is somewhat what I do is kind of blur it all out, and then I don't need to make the substitution anymore. So again, I'm going to use the same problem, but I'm going to make just a small change. So this is going to become 2 times 2x minus 1, and this time it's squared, plus 10 times the same quantity, 2x minus 1 cubed. Now the greatest common factor, if I were doing a factoring by grouping problem back in intermediate algebra, these would both be 1s. I'd factor out the 2x minus 1. But that's not the case here because I've got them raised to powers. So I'm going to make a substitution. So I'm going to let u be equal to that set of parentheses which has 2x minus 1 embedded in it. Now you could pick any letter you like. You could use B, B for blob. I use U because that's more standard from a mathematical point of view. So what am I going to have? I'm going to have a 2. Now this set of parentheses is what U is, and so that becomes U squared, plus 10, that set of parentheses is what U is, and that's U cubed. And if you take a look at it, except for the letter, it's the first problem we worked. So do we know how to work this problem? The answer ends up being yes. We've now simplified it down to something that we know how to do. So greatest common factor is 2u squared, and I'm going to be left with 1 plus 5u. But the original problem didn't have a u in it, it had an x. So what I need to do is to come back over here, and I'm going to re-substitute for u. So wherever I have a u, I'm now going to put the 2x minus 1. So this becomes 2x minus 1 squared, 1 plus 5 2x minus 1. So now I've resubstituted it back in, and now what I do is I simplify, combine, and then combine like terms. So I have 2 times 2x minus 1 squared, 1 plus 5 times 2x is 10x, 5 times minus 1 is minus 5, or 2 times 2x minus 1 squared, and then I have a 10x minus 4. Now, unfortunately, I still have a greatest common factor of 2. So this would become 2 times 2x minus 1 squared times greatest common factor of 2, 5x minus 2. 2 times 2 is 4, so my final answer is 4 times 2x minus 1 squared times 5x minus 2. Now, the purpose for this, especially from a calculus standpoint, is eventually what we would do is we would set this equal to 0 and solve for x. We'd have a hard time doing it up here without multiplying everything out, and then I'd have a cubic, and I don't know how to solve cubic. So at which point